All right, so this is going to be our second video for 3.2. We left off factoring a trinomial where a was 1. So now we're going to move into a trinomial where a is greater than 1. First thing I want to actually cover before we even do that, because I mentioned earlier that the sum of squares um, is not factorable. So we'll just kind of put this in here. If you had something like this, x squared plus 9, there is no way to factor that one because of the plus in the middle. You can't say that x plus 3 times x plus 3 works. You can't say that x minus 3 times x minus 3 works. There's no way to factor this one. So this is what is considered to be prime. There are no real factors. And I stress the word real here. There are no real factors. We will actually learn a way to factor this, but they are not going to be real. And for a polynomial to be factored, or excuse me, to not be factored using integers, meaning non-positive or negative whole numbers, that is what is considered to be a prime polynomial if it cannot be factored using integers. So that's what you would get if you were doing something which is prime. Okay. Our next topic, let's scroll back up before, was by grouping. So we're going to factor by grouping. These take a little bit longer to do. I want to kind of do the grouping part, and then I want to come back to factoring a trinomial with an a value of greater than 1. There's actually a reason for doing that. Because once you learn factoring by grouping, you can actually factor a trinomial with an a value greater than 1 in multiple ways, and you will be able to pick that way. So for right now, let's go ahead and factor by grouping. So, and I know that we have talked about this, if we had something like x squared plus 2 times x plus x squared plus 2 times 3. What you should notice is that I have x squared plus 2 in common in both terms. Both of these two things are terms because they're separated by addition. So they're things which are being multiplied together, but they're separated by addition. So x squared plus 2 is a common factor. I can factor out x squared plus 2 from each one of these pieces. If I take x squared plus 2 out of this term, it just leaves me with an x. If I take the x squared plus 2 out of this term, it just leaves me with a plus 3. And now that's been factored. So that's kind of like how it's going to work. I'm actually giving you the middle steps of factoring by grouping in order to show the entire factoring by grouping. We're going to do a different problem. Most of the time you're going to use factoring by grouping when it comes to something that has a polynomial which has 4 terms in it. So that's what we'll actually see. When we do a polynomial with 4 terms in it, we're going to do that by grouping. I want to do one more example, however, of something that doesn't look normal. So let's say that we have 3 times x minus 1 squared, x plus 2 to the 4th, plus 4 times x minus 1 cubed times x plus 2 to the 3rd power. So what you need to look for is what common factors do I have in both terms. Now remember, this whole thing here is a term. That whole thing there is a term because they're all being multiplied together. Do I have any common factors with the 3 and the 4? It doesn't look like it. 3 and 4, no common factors other than 1. X minus 1, however, does have common factors. I have 2 factors of x minus 1 here. I have 3 factors of x minus 1 there. The most you can ever factor out is the smallest of the exponents. So I can factor an x minus 1 squared out of both of those pieces. I also have x plus 2's in common. This one has 4 factors of x plus 2. That one has 3 factors of x plus 2. So again, the most I can factor out is the smallest of the exponents. So I can factor out an x plus 2 cubed. Well, that is going to leave us with some remaining stuff. So let's see what that leaves us with. The 3 is still in the first term. I took both of the x minus 1's out of this first piece. So they're gone. I only took 3 of the x plus 2's out of this first piece. So there's still an x plus 2 left over. Plus, now we're going to go to this other piece. Again, I can't do anything with the 4. It stays there. I took 2 from this one right here out of the 3 x minus 1. So I am still left with an x minus 1. And then I took all of the x plus 2's out. So that is going to be simplified to that one. So I've still got an x minus 1 squared. I've got an x plus 2 cubed that I factored out. I can now distribute the 3 into the x plus 2, the 4 into the x minus 1, and then combine some like terms and see what that leaves us with. We may have to do some more factoring. We'll see. So if I distribute the 3, we get 3x plus 6. If I distribute the 4, we get 4x minus 4. So rewrite the x minus 1 squared, the x plus 2 cubed. Let's combine our like terms. Looks like we're going to get 7x. 6 and negative 4 is 2, so plus 2. There's no more common factors in that, so that one is completely factored. Different way of thinking about grouping. These things were grouped in an odd way. The most part when you're talking about grouping, we're going to have an example that looks like this one. X cubed minus 4x squared plus 2x minus 8. There are 4 terms there, so using some kind of a reverse FOIL doesn't really work here. But I do recognize that if I group these first 2 terms together, and I group the second 2 terms together, each one of those groupings has something in common. I can factor a common factor out of each one. In the first grouping, in that first parentheses, I can factor out an x squared. I can take the x squared out. If I take x squared out of x cubed, that leaves me with x. If I take it out of negative 4x squared, it's minus 4. In the second parentheses, in the second grouping, I can factor out a common factor of a 2. So if I take the 2 out, that's going to leave me with an x and a minus 4. That's what I was hoping for. What we were hoping to see, this goes back to our first example, is that now I have 2 things in these parentheses, 2 quantities, which are identical. Those are now the common factor. I can factor out the common factor of x minus 4. If I take the x minus 4 out of this piece, that leaves me with x squared. If I take the x minus 4 out of this piece, that leaves me with plus 2. And now that is completely factored using the grouping method. Okay, that's not so bad if you have the 4 terms. That's what you're looking for. Now, it is possible that if you try and group these things and you do the common factors, maybe what's in the parentheses doesn't match. And if that's the case, it's probably just a prime polynomial and you can't factor it. So that is a possibility. Look for that. So now let's kind of go back to the whole factoring something with an a value of greater than 1. So if I've got something with an, excuse me for that, sorry, there was a little bit of a noise in the background there. So I've got something where the a value is greater than 1, like 2x squared plus 5x plus 3. I don't prefer to use the grouping method here, but it can be done. Again, it's a bit time consuming, but it is something that will work. I prefer to personally still try to do a reverse FOIL method here, and that would be my choice. So as a matter of fact, I'm going to do the reverse FOIL method first to show you that it's actually pretty short. Then I'm going to show you how to do this one by factoring by grouping, just to show that it gives exactly the same value. So if I was going to factor this one, should be two binomials. Again, I have to look at this first term. Now, in this case, it's not a 1, so I can't just put x and x. I'm going to have an x in each one, but now the coefficient has to be there. The factors of 2, fortunately, in this case, are very easy. It's just 2 and 1. So that means there has to be a 2x and an x. Okay, that I really don't have a choice of. In order to get the last components here, that's going to come from this piece. Well, again, fortunately, the only factors of 3 are 3 and 1. The biggest thing is the placement of the 3 and the 1 matters because of the fact that it's a 2x and an x, not just both x's. So I could put the 3 here, and I could put the 1 here. And I believe this one's going to work out for us, because if we check the outside, we would get 2x. If we check the inside, we would get 3x. Can I add 2 and 3 and get to that middle term of 5x? I certainly can. So that was the right choice. If I had switched those, I'm going to put the 1 and the 3 back in a second. If I had switched those on accident and put a 1 here and a 3 here, when I checked the outside, I would get 6. When I checked the inside, I would get 1. I can't add 6 and 1 to get to 5. It would give me 7. So that's why the 3 and the 1, the order makes a difference. Okay, this is not that hard to do as long as the numbers are relatively small. When we start throwing negatives and stuff in there, minus signs, maybe it gets a little more challenging. So let me show you how you might do this if you were going to factor by grouping, and show you that the process is a lot longer, but it does work. What you want to do is you want to create a chart. On this side of the chart, we want to do A times C. And A times C is A, which is 2, times C, which is 3. So that's going to be 6. Actually, let's put that up here, 6. I got to come up with the multiples of 6. What things multiply to give me 6? Well, 1 times 6, 2 times 3. You could also include the negatives. I'm not going to in this case because this middle term here is positive, so I'm not really worried about the negatives. In this side over here, we want to do the difference, which is going to be your B term. Well, what's the, sorry, not the difference, the sum. I apologize. It is the sum, which is going to give you that B term. The B term is the 5 here. So if I take 1 plus 6, that's 7. That's not going to work. 2 plus 3, that's 5. That one works. So what does this actually give us? This 2 and this 3 gives us a way to split the 5x. So again, this is going to be a longer process. So if we split the 5x, the 2x squared stays the same. The plus 3 stays the same. These two things are now going to let you split the 5x to be 2x plus 3x. Hopefully you can see that that middle, that 2x plus 3x, it's still 5x. It's still the original function. But now I've created 4 terms. Now we can factor by grouping. Run through it a little bit quicker. If I factor by grouping, the common factor of the first parentheses is 2x, which is going to leave me with x plus 1. Don't forget, if you take the 2x or divide the 2x out of 2x, it's still 1. The second grouping has a common factor of 3, which will also leave me with an x plus 1. The x plus 1 is now the common factor using grouping, which will leave us with 2x plus 3. That is the identical answer to what we had before. Again, this works all the time. It's a little bit of extra work, but it is a method. I still prefer to use the method of trial and error. I think the reverse FOIL is just a little bit easier to do that way. That's just my personal opinion on the matter. Let's do one more example, and I'm going to still do this one with trial and error, but you can use grouping if you choose to. So we're going to have 2x squared minus x minus 6. Again, a little bit of trial and error. As long as these numbers are relatively small, this isn't that hard to do. Has to be a 2x and an x. That's the only way I'm getting that first term. The factors of 6 are 1, 6, 2, and 3. I'm pretty sure that if I try a 1 and a 6, that's not going to get me anywhere near to adding up to -1, but let's just see. I plug a 1 and 6 in there. If I do the outsides, I get 12. If I do the insides, I get 1. I can't subtract 12 and 1 and get to 1. That's not going to work. Let's try the other order. Let's put the 6 and the 1 here. Well, now if I try the outsides, it's 2x. If I try the insides, it's 6x. Can't subtract 6 and 2 and get to -1. I can get to 4. That's it. So that definitely was not the right combination. Of course, I knew that. I was just putting it in there. So it's got to be a 2 and a 3. Well, let's try the 2 and the 3. See what we get. If you look at the outsides, you're going to get 6. If you look at the insides, we get 2. We just did 6 and 2, and that's not, of course, going to give us 1. It can give us 4. So that's the wrong order. Of course, I picked all the wrong orders just to make it show how the trial and error works. Now, if I do the outsides, I get 4x. If I do the insides, I get 3x. I can subtract 3 and 4 and get to a 1 or a -1. I need it to be a -1, which means that the 4 has to be negative. So the minus sign is going to go here, and the plus sign is going to go there. Now it should all work. That one is completely factored. So again, as long as you can do a little bit of mental multiplication, addition, and subtraction, it's a little trial and error. It's not too bad. Now, if you get factors like 24, that one's horrible because you have so many different factors that you might have to try. A little intuition there might be a good thing. All right, one more topic, and then we will be done. We need to talk about completing the square, and this is probably the most difficult of the topics. So this is our last topic. Is this 5 or 6? 5. Completing the square. So what we're going to be given is we're going to be given some kind of a polynomial to factor. But the polynomial itself is going to be, let's just say it's going to be something that doesn't factor easily. So for example, if I have x squared plus 8x plus 2. Okay, if you look at that one, the first thing you might try is say, okay, let's try and figure this thing out. So if x and x, factors of 2 are 2 and 1. I can't add or subtract 2 and 1 to get to 8. So that's not going to work easily. There are going to be other methods that we will learn to factor this, but that one's not going to work out nicely for us. I can do a process which is called completing the square. What we're going to do is we're actually going to group the first two terms, the squared term and the x term. We're going to separate the constant. It's still going to be part of the expression, but we have to just keep it separate. So I'm going to write this as x squared plus 8x. I'm going to leave a space and then separate the plus 2. To complete the square, this is the process, and then after we do it, hopefully I'll be able to explain to you why it's called completing the square. What you're going to do is you're going to take a look at the b term. Oops, that should be in red. In the b term. And you're going to divide the b term by 2. So it's going to be b divided by 2. In this case, excuse me, that would give us 4. And then you're going to square it. So if I divide 8 by 2, that's going to give us 4. When we square it, it's going to give us 16. We are going to add 16 inside that parentheses. Now, we do have to be careful here. We just added 16 to an expression. You can't just arbitrarily add something to an expression because it's now changing the expression. So if I add 16 to the expression, As long as I subtract 16 again from it someplace, I'm keeping the balance. So I can subtract 16 out there. So now really all I've done is I've added 16, subtracted 16. I've really added nothing, right? I've added 0. But I have to do something to manipulate this, which is why I'm doing it this way. So what we're going to do now is we are going to show why this is called completing the square. This piece right here is now a perfect square trinomial, and we covered that earlier. The first term is the square of x. The last term is the square of 4, right? 16 is the square of 4. So if I factor this, I'll have an x and a 4. If I multiply 4 times x and double it, do I get that middle term of 8? I sure do. And they're all positive, so that gets to be a positive, and that is x plus 4 squared. Only other thing I have to remember to do now is to do the 2 minus 16 on the outside, which gives you negative 14. Okay, so one of the reasons for completing the square is because it's going to help us to solve equations in the future. But that is the basic idea on how to complete the square. Okay, these can get obviously a bit more challenging when it comes to completing the square, and I'm not going to go into the higher level ones just yet, but if we come across them, then we will. That is it for this section. Hopefully that's enough for you guys to get through the first 2 sections. The homework on this will actually include section 3.3 as well, but we won't have covered that one yet. So just do as much of the homework as you can get through with the factoring.